Our meeting will be a little bit short. I will continue tension member. Before starting last meeting or last meeting, Brock asked me a good question. Area net equal area gross minus summation d whole plus 1/16 time t. T only time this part, and then you will do summation. Sometimes this equation can be written like this. Probably if you open the standard for AISC, American Institute of Steel Construction, you can find area net equal B, not area gross, B minus summation d whole plus 1/16, all of them time t. He or the standard assumed we have a plate. This plate has a width equal B and a thickness equal T. Guys, if you multiply this B, which is the width, by this T, which is the thickness, you can get area gross. Then you will have minus summation d whole plus 1/16 time t. That make sense? That make sense? Don't be confused. Don't be confused about this equation or this equation. Actually, I don't pay any attention to them. My attention is we have a cross section, whatever the shape, so we have area gross. This cross section has some holes. We need to subtract the area of these holes. That's it. If you would like to get the area net, that's it. You need only to understand this concept. Area net equal the total area without holes minus the area of the hole. If you would like to figure out what is the area of holes, you need to get the diameter of the hole, one hole. You need to add another 1/16 inch, and you need to multiply this diameter by thickness. And you need to get how many holes do you have. All of this stuff will be subtracted from the total gross area. That's it. That makes sense, Brock? Okay. Yeah, I understand. If you open the standard, I believe you can find this one, not this one. Okay? But regardless what is this one or this one, regardless these equations, you need to understand the concept. We have area gross, whatever. How can I get the area gross? From the table or from width times thickness, whatever, minus the area of holes. That's it. Okay, we have an example here, and we need to design. I remember one of these, one problem looks like this, can be a problem or a question in the PE exam. We have a long tensile member is constructed by connecting two plates. We have two plates, two steel plates connected together by this or by these bolts. That makes sense? Okay. Each plate is half-inch thickness and 9-inch width. If you follow the given information, this thickness 0.5 and the total height or width of this plate is 9. 2 plus 2.5 plus 2.5 plus 2, it will be 9-inch. So by the way, if you are looking for the area gross of this plate, area gross will be 1/2 times 9. The area gross will be 4.5 inches square. This is the first step. By the way, we have steel. This is steel with type A 572 grade 50. So if you open your notes, module number 1, if you go down, we have type of steel here, A572. That's the same, 572. So what is the value of F yield? What is the value of F ultimate? 50 and 65. So F yield is 50 KSI. F ultimate is 65 KSI. It's a given. The yield stress is 50. The ultimate strength is 65. If this information are not given, you can get them from this table based on the type of the steel. The fasteners or the bolts are 1/2 inch diameter. So D bolt equal 1/2 inch. That means if you are looking for D hole, it will be 1/2 inch plus 1/16 inch. This one will be 9/16. Using the ultimate design, determine the design ultimate strength of the member. If you go back to your design steps, we have yielding criteria and we have rupture criteria. For yielding phi PN, because we are looking for design, not nominal, equal 0.9 area gross time F yield. I believe I can get it right now. That's right? Yeah, 0.9. Area gross for one plate is 4.5. F yield based on the type of the steel is 50. So the design ultimate strength to satisfy yielding will be 202.5 kip. This plate or this member, this tensile member, can support a force, a tensile force equal 202.5 kip without yielding. However, we need to check rupture. Rupture is related to the location of the bolts. We have phi Pn equal 0.75, which is the value of phi. The value of phi here is 0.9. Area effective time F ultimate. Everything is known in this equation. F ultimate 65, phi 0.75, area effective, this is the only unknown. So we need to figure out the value of area effective. I understand that area effective equal U time area net. Anybody here can tell me what is the value of U? What do you think? Please remember what is the concept behind you, and then you can decide what is the value of you. What do you think? Do you remember what is the concept behind you? Thank you, Burak. Yeah. Any other answer? Guys, I told you before, we have issue. We have issue with member. Looks like this. For example, or looks like this. For example, I-beam. For some reason, we connected this member by this plate only. That means the remaining part of the cross section is free, did not connect it, or hasn't been connected to the gusset plate. So we have something called shear leg. The shear leg factor is U. So we have a value here, smaller than 1. For this angle, probably we will connect this leg only with this gusset plate. That means the remaining leg is free. So we have the effect of shear leg. That means we have U as a shear leg factor smaller than 1. In our case, the member is given as plate. And this plate is connected by another plate or another gusset plate, whatever. By this hole or these holes. Do you think we have a part of this member or even this member is free, is not connected? We have only one part, this part, which is connected. That means U equal 1. We don't have issue with the shear leg. So U will be 1 times area net. That means you can figure out the value of area effective. How can I figure out the area net? Any recommendation? The connection looks like this. So area net, I believe, equal, we have two equations for area net, if you remember. Area gross minus summation d whole plus 1/16 times t, or area net equal area gross minus summation d whole plus 1/16 times t plus summation s square divide, I believe, 4g, I think, times t. Which equation I'm gonna use? Any answer? What do you think? The arrangement of these bolts are not staggered or are not parallel to each other. We have something called combination. It's confused a little bit. So what do you think? Okay, let me think. We can expect the mode of failure. if you can expect what will happen if this part of the member is ruptured, we have failure. Probably this failure will happen through this plane or through this plane, or probably the cracks or the rupture in the member will be like this. Why not? So we have 3 expected failure. That makes sense? I believe number 1 is not critical because number 2 is more critical. Do you know why? Because number 1 has only 2 holes, but number 2 has 3 holes. So critical or section number 3 will be, I'm sorry, section number 2 will be more critical. So let's try if we have this case of failure. Area net will be area gross 4.5 minus how many bolts? 3. D hole 9/16 plus 1/16 times thickness 1/2. If you are trying this one, you will use only 2 holes. If you are trying this one, you are going to use only, 3 holes. So the second one will be more critical. So I used the second one. I forget the first one. I'm looking for the section will give me the least number of area net. So 4.5, 9/16 first, plus 1/16 is 10/16 times 1/2 times 3 plus 4.5. This one will be 3.56 inches square. If you try the expected failure number 3, your area net will be area gross minus how many bolts in this one, in this base? 1, 2, 3. Okay? 9/16 plus 1/16 times 1/2 plus summation to S square divide 4G. Why 2? Why this summation for S square divide 4G times T? Why 2? Because how many inclined part? This part and this part, that means we have 2. So this summation will be 2. What is the value of S? Is the spacing. What is the value of G? Is the gauge length. This information can be found here. S will be 2.75 square. 4 times G, the gauge length between this one and this one is 2.5. One of you will say, hey, probably I don't need to get this value because I believe 100% this one will be the least one. Do you know why? Because this term and this term are the same. And this term will be extra, will be added. That means I expect a value here greater than 3.56. If you would like to take this decision before calculating anything, if you don't have any idea, okay, go ahead and get your numbers and you will find this one will be the least number. So 3.56, here is the value of area effective. Put your number here, 3.56, multiply it by 65 by 75.75. This number will be 173.6 kips. So guys, this member to satisfy yielding can support a load of 202.5 kip. This member using these connections of bolts to satisfy rupture can support only 173.6 kips. So what is your final conclusion? What will be the design ultimate strength of this member? Do you think the design ultimate strength will be 202.5 or 173.6? We need to satisfy both of them. We need to satisfy both of them. We need to satisfy yielding. We need to satisfy rupture. That means the design ultimate strength will be 173.6 kip. Does that make sense? Yes, thank you. Thank you, Cody. Yep. You did what I covered. This addition will add a little bit. So if you would like to think before calculating, that will be great. If you cannot judge what is the situation, okay, go ahead and assume, go ahead and get area for this expectation, get area, and then use the least one. Any question? So can any one of you give me a number? I believe during the homework, you should analyze this truss under the effect of dead, life, and the snow load. That's right. Can anybody tell me one member? Let's assume this member. I opened RISA and I found the P ultimate, which is tension. Let's assume how much? What do you think? Okay, let's assume it 75 kip. We need to design this member. I will do a real design with you right now. But this member, this one is M1, this one is M2, this one is M3. So I will open Excel to show you how to use Excel in your design. So we assume from RISA, you have each number of member. That's right. I think RISA will give you the name of the member as M1, M2, M3, M4, M5, whatever the number of member. Then I can figure out the value of P ultimate. I'm talking about right now, guys. I'm talking right now about format cell, alignment, center, merge, font, bold, 12, design of tension members. I'm talking about design of tension members. So this truss, I will select which members are tension, and I will list them in this Excel file. And from RISA, I can figure out the value of P ultimate of each member. For example, I will assume this one is 75, this one will be 40, this one will be 25, this one will be 39, and this one will be 60, for example. And if you'd like to be more specific, this P ultimate in kips. Guys, can you tell me what was the first step? Do you remember in our design, what was the first step? I decided, because these members are bottom chord, I will decide to use double angle. Can be written like this, or can be written like this, 2L, or double angle. So I decided, I take a decision. Any member at the bottom chord, all of them will be tension. I decided to use double angle. It's up to you. If you would like to use single angle, nobody can say it's wrong. It's up to you. But the common sense, we are using double angle. So the first step, we need to satisfy yielding. That means the design strength equal 0.9 times area gross times F yield. I decided also to use area steel. What is the value? It's up to you. 36? Okay, 36. That means F yield for this type of steel, 36. F ultimate will be 58, I think. KSI. Please, these assumptions must be written in your project. You have to tell me what is the type of steel. And based on your assumption, you decided, or you started to design. Okay, so the most critical part, I will assume phi Pn equal P ultimate. So P ultimate equal 0.9 times area gross times F yield. If you would like to get area gross, you have to divide P ultimate by 0.9 times F yield. That makes sense? So the first step in the Excel file, I will figure out the area gross in inch square equal this number divide .9 time F yield, which is 36. So you can get the required area gross for all of them. Any questions so far? If you have any question, let me know. So whatever the number of members, I believe your truss will be more very big. So probably you have around 20, 25 members in tension, 30 member, whatever the number. You can list them. By the way, if you have full version for RISA on Canvas, you can export. You don't need to write each member by member. You can get copy from RISA to Excel, or you can export. You don't need to write each member. Okay? So whatever the number of members, you need to do calculation for one of them, and then double click here. You can repeat this calculation for all members. One more time, I'm talking about design of tension members only. I didn't talk about compression member. So selected section. We need to select a cross section. So to do this, you need to open tables and go down for angles. Remember this area gross for two angles. This required area gross for two angles. This area in this table only for one angle. So be careful. So when you select a member, you need to divide this number if you would like. Okay, let's do it. So area gross in inch square for one angle to be more easy. Well, I will divide this number by 2. So you can easy select what you want. So the first one, I'm gonna select the area gross 1.15. So area gross 1.15. I highly recommend to use the equal legs. Equal legs. Let's start with this one. 8 by 8. It's too much. 6 by 6. Too much. 8 by 8. No, this is not the case. 5 by 5. Too much. 4 by 4. Probably here. How much you need? 1.15. 1.93, that works. So you can select 4 by 4 time 1/4. Or if you don't like, if you are feeling it's still too much, remember, after this yielding, we need to make check of rupture. So don't be critical. I believe this cross section will work. 4 by 4 time 1/4. The area gross is 1.93 for one angle. You need cross section with area gross for one angle 1.15. So this one will be good. So I'm gonna use 2 angle 4 time 1/4. What is the actual area gross? Equal from the table, the actual area gross 1.93 for one table. I'm sorry, for one angle. So you need to multiply it by 2. What is the area net? What is the area effective? And what is the pay or rupture check? What is the value of area net? How can I get the area net? We don't have any information about the connection. That's right. Probably by the end of next week, we will have this information. We will design how many bolts do you need, what is the diameter of the bolt, what is the design of the connection. So until the end of next week, we are going to assume we have welded connection. Okay, so the area net will equal the same value for area gross. And the area effective, we are going to assume area effective equal U time area net. I'm going to assume area U equal 0.75. So the capacity against rupture equal 0.75 time area effective time F ultimate equal 125. Do you think 125 is greater than this capacity against rupture, greater than the B ultimate? Yes, it is. So it's safe. Second section, the area gross for one angle 0.617. So I will open the table, go down probably 3 by 3. Let's try 3 by 3. Probably will be good. Here you go. So the area gross, we have here the minimum one is 1.09. So we need less 2 by 2. Do we have 2 by 2? Yes, we have 2 by 2. Where is 2 by 2? 2.5 and 2.5. the minimum area 0.9. We need 0.6. Okay, 0.9 will be good. This cross section, I'm sorry. This cross section will be fit 2.5 times 2.5 times 3/16. The area gross will be 0.901. We have less. We have a smaller angle, 2 by 2, and we have a smaller area gross. But I highly recommend don't be more critical. You are looking for 0.617, okay. 0.9 would be good because you still need to do a check against rupture. So we don't need to be unsafe here. And keep going. Keep going. Finally, by the end of this process, I have the label of the member. So I can figure out where it is. What is the P ultimate from RISA? What is the selected cross section for this member? Any question? Guys, any question? So until this moment, we are designing the member, and we assuming the end of the member is connected by welding. That means area gross will be the same like area net. Next week, by the end of next week, next Thursday, we will be able to figure out if the B ultimate in this member from RISA analysis equals 65 kip. I will let you know how to determine how many bolts do you need and what is the distance between each bolt and what is the diameter of each bolt. Once you figure out the connection, you can actually or accurately calculate the area net and the area effective. Does that make sense? That makes sense? So by the end of next week, we are going to assume area gross equal area net if you would like to start to design using Excel or to practice how to design. Guys, anybody has any question about how to design tension member? How to design tension members in the truss? And just for your information, for practice, for reality, can you watch this truss? Do you think each member has a different cross section? Do you think you are wasting your time if you decided to design this member alone, 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 this member alone? Doesn't make any sense. Probably you need only to figure out what is the maximum tension force in this member. So the maximum value, for example, 75. From your design, I decided 75 will be satisfied with a double angle 4 by 4 by 1/2. I will decide to make this member for the whole members at the bottom port. For the diagonals, I will figure out for all tension member, which member has the maximum value. Design it, and I will use this design for the remaining member. As you see, this diagonal looks like this one, looks like this one, looks like this one. To make fabrications very easy, to make construction easier. Because it doesn't make any sense to this one looks like different than this one, different than this one, different. No. we have standards, we have members will be the same for this member, for this one, and this one. Okay.